We're going to walk through the third and fourth sides now of the Intro to Polars notes. And before you watch this video, I hope that you've watched the previous video that went over how to play the activity about finding more boats and then try to find a few on your own. Now we're going to do one just on this hard copy. So it says, you're a Coast Guard officer. Help rescue the ship lost at sea. So you, a Coast Guard officer on duty in the control tower, received an emergency call from a ship lost at sea. You've identified the ship on the radar, but now need to give directions to another Coast Guard officer who will rescue the ship at sea. What directions will you give that other officer? So we see the radar just like we did in the online activity, and now we need to locate the ship. So remember, if we want to figure out the angle of rotation, I'm going to label a few on our grid. So we have 0 degrees, 90 degrees. Across the other side would be 180 degrees, and on the bottom is 270 degrees. For this particular ship, we're really just in the first quadrant on the rectangular plane, so we don't need the other ones, but I'll put them in for good measure. And then remember, each one of these lines or rays is 10 degrees. So I'm going to put those in, counting by tens. And now we can locate our ship. So our ship is at, we want to know about the angle of rotation. So the angle of rotation is 70 degrees. And then we want to know the distance from the pole. So the distance from the pole, remember each one of the bold or white circles is 3 units. So we can go ahead and count that. So we would be here, we would be at 3, 6, 9. So our ship is at 10 units from the pole. So we're at a distance of 10. And that's all we know. Now going forward, we're going to write this as 10 units from the pole and 70 degrees. I'll put that down here, and that'll become more apparent later. Okay, the next example, it says, after a midlife crisis, you made a career change. You love giving directions, but now you're directing airplanes. You are now working in the control tower at O'Hare and need to be able to identify the location of all the airplanes. It says O'Hare Airport is located at the center of the grid, and then we have points A through F that represent planes approaching O'Hare for landing, and we need to describe the locations of the planes in relation to the airport, which is at the center of the grid. It says spacing for the circles is 1 mile. So as we move out from one circle to the next, moving concentrically further away, we go out 1 mile each. So I am going to put on some angles for reference. So I'm going to actually draw in, so it's a little easier to see the horizontal and vertical, because I find with so many lines, it's a little hard for me to see. And then I'm going to put in some angle measures. And so you can pause the video and put in some angle measures yourself and then rejoin, or just go ahead with me. So 0 degrees is on the right side, 90 degrees is at the top, 180 degrees is across on the left side, the negative x-axis, and the bottom will be 270 degrees. And then each one of these lines, let's count how many we have. We have 1, 2, 3, 4, 5, 6, 7, 8, 9 lines going across 90 degrees. So 90 divided by 9 is 10. So each one of the rays is 10 degrees. So we'd have 10 degrees, 20 degrees, 30 degrees, 40 degrees, 50 degrees, 60 degrees, 70 degrees, 80 degrees. Actually, I'm going to move where I wrote 90 degrees because it's kind of in the way. So let me erase that. I'll rewrite it. 90 degrees up here. We don't need all of these because we're just trying to find the planes given by the points denoted. So where B is, that's 120 degrees. And let's see, where F, let's do this over here. So we've got 270, 280, 290. This one would be 300, 310. Where F is 320. And let's stop there for now. And that's enough angles for reference. The next thing we need to figure out is how we are going to concisely give the coordinates for a point on this coordinate system. And you can stop the video and think about it yourself, and then come back. So the way that's traditionally given for naming points in this sort of system is there's two pieces of information. We have the distance from the center, or distance from the airport in this case, and the amount of rotation. And the way we typically will write these, we're going to give the distance and then the angle. Okay, so those would be the coordinates. It says hint, find the angle first. That's the way I like to do it, but I really think you can do it either way. Whichever way makes sense to you. I like to find the angle first and then the amount of the distance, but you may want to find the distance and then rotate it. So whatever works for you. Okay, so let's start trying to find some of these points. So let's first try to find, locate point A. So point A, what is the amount of rotation? So we can look at point A and we see that it's on the ray associated with a 30-degree rotation. So I'm going to put that onto my grid here, or I'm on the line here. So it's 30 degrees. And then how far is it from the pole? So now we have to count. And we were told that each circle is 1 mile. So we're going to count out. So A is on 1, 2, 3, 4, the 5th circle out. So it's at a distance of 5 miles at 30 degrees. Let's do the same thing for point B. And feel free to stop the video and try some of these on your own and then come back, because the best way to do these is for you to find them on your own. So for point B, I can see that point B is at an angle of 120 degrees. So I'm going to write that down, 120 degrees. And then I want to figure out how far it is from the pole. So I'm going to count the circles going out to B. So I'd have 1, 2, 3, 4, 5, 6, 7, 8, 9. So B, plane B, is 9 miles from O'Hare at an angle of 120 degrees. Okay, go ahead, stop the video, try point C, so, and then come back. So for point C, its angle is at 270 degrees. And then the distance, so now we just have to count down. So we have 1 circle, 2 circles. So 2 circles out means it's going to be 2 miles. So we have a point 270. Point D, same thing. Pause the video, try it on your own. The angle for point D is 180 degrees. So let's write that down, 180 degrees. And then the distance, we need to count how many circles we are out from the pole. So 1, 2, 3, 4, 5, 6. So this point is at 6, 180. Point E, the angle is not on one of the rays that's shown. So let's figure out the angle here. So I had marked 180 earlier. So the next one is 190. The next ray is 200, then 210, then 220, and then 230. And E looks like it is midway between 220 and 230 degrees rotation. So I'm going to estimate that at 225 degrees of rotation, the angle, and then I'm going to count how far out it is from the pole. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So I counted 9 circles, so it's 9 miles from the pole at an angle of 225 degrees. And the last point that we need to find is F. I'd already marked the angle earlier, so F is at 320 degrees. And then let's count how far we are from, how many circles from the pole. That's the distance. So 1, 2, 3, 4. So 4 miles at 320 degrees. Okay, now we're on the second side of the Intro to Polar's Day 1 notes, and we're going to define some vocabulary so that going forward, we'll all be speaking really the same language when using this polar coordinate system. So first off is we have the pole. So the pole is the origin of the polar coordinate plane, and this point right here is the pole. It's labeled O in the diagram to the right. The polar axis is what would have been the x-axis in the Cartesian coordinate plane, and it's where we normally would draw 0 degrees of rotation. So this is the polar axis. And then so we have polar coordinates. We're labeling two things, which is the distance from the pole and then the amount of rotation. So a polar coordinate is designated as r theta of this point P. Right? So r indicates the distance from the pole, so it's the length of this segment right here that I'm highlighting. A negative sign before the r indicates that the point is reflected over the pole or rotated 180 degrees, or we could say pi radians from the pole. So what you're really going to do is reflect the point over the origin for a negative r value. So we see this point here, negative 2 pi over 6. The reason it's negative 2 pi over 6 is what we were thinking of here is we would go, if we had positive pi over 6, and then we're actually going negative 2 units in that direction, which means we flip over the origin or rotate 180 degrees, and then we go out 2 units. That's what negative 2 pi over 6 means. And then theta is the amount of rotation. So back to this first point P, theta is the amount of rotation from the polar axis, okay? And positive rotations are like we've been doing all year. If theta is positive, the direction of rotation is going to be counterclockwise. And if theta is negative, the direction of rotation is clockwise, which is consistent with what we've done, what we did with vectors and unit circle angles. Okay, so the point that we show here, for example, this is the point 2, 3 pi over 4, because it is a distance of 2 units from the pole, and the amount of rotation is 3 pi over 4 radians from the polar axis, right? The polar axis is here. Okay, so we're going to practice plotting some points in the polar coordinate system. So here we have a coordinate plane, I would say, and I'm going to label some angle measures on it. So I'm going to go ahead and put in the horizontal and vertical just so that it's a little easier for us to see what the angles are. I'm just going to highlight those. And now let's put some angles in, just like when we were doing the unit circle. We're going to be naming these points in radians. Okay, so I'm going to label these in radians, angles in radians. So that's 0 radians. The top, or at 90 degrees, is pi over 2 radians. If we go across, we'd be at pi radians. And if we go down to where 270 degrees is, that would be 3 pi over 2 radians. And now we have to figure out what these designations are in terms of these rays. So let's count here, see how many we have. We have 1, 2, 3, 4, 5, 6, 7, 8, 9 in 90 degrees. So each one of these is 10 degrees. So remember, 30 degrees is the same as pi over 6 radians. So if I counted 1, 2, 3, this would be 30 degrees, which is pi over 6. And then 60 degrees is pi over 3. So I'll go 3 more, 1, 2, 3. This would be pi over 3. Then we'd be at pi over 2. If we want 3 more lines, 1, 2, 3, pi over 2 is 3 pi over 6. This would be 4 pi over 6. But if we simplify that, we get 2 pi over 3, which is what's going to be relevant for this point. We don't need to label all of these angles The other ones that are going to be helpful, if we have 3 pi over 2, 3 pi over 2 is the same thing as 9 pi over 6. If we go 3 more lines, that'd be another pi over 6. So that would be 10 pi over 6, but if we simplify that, that's going to turn into 5 pi over 3. So this ray, I'm actually going to, I'll highlight this ray for us. This is 5 pi over 3, and going across the unit circle, that's 2 pi over 3. That's going to help us with this particular problem. Okay, so let's try to plot the point 6, 2 pi over 3. So we did all that really just to figure out where 2 pi over 3 was. So once we find that ray, then we can go ahead and count out 6 circles. We need to set a scale. So I'm going to say that each circle is 1 unit. And that'll work fine because I only need to go to 6 units away. So now let's count out 6 units on the ray 2 pi over 3. So 1, 2, 3, 4, 5, 6. So this is going to be our point A, and its coordinate is 6, 2 pi over 3. So we've plotted it. Here it says, lists more ways to describe the location of point A. So this is kind of something that's different with the polar coordinate plane than with the rectangular coordinate plane. In the rectangular coordinate plane, each point has only one name. So if I asked you to plot the point 2, 3, you plot it. Let's say we're going to plot the point 2, 3. I plot it, and it only has one name, 2, 3. I cannot name it in different ways. In the polar coordinate system, I can actually name a point in an infinite number of ways, and let's see how we get some of them. Okay, so we plotted point A, 6, 2 pi over 3. How else could we name this? Well, we could name it by getting a coterminal angle. For example, if we take 2 pi over 3 and we add a full rotation, right, that will leave us in the same location. I'm going to get a common denominator multiplying by 3 over 3. So 2 pi over 3 plus 6 pi over 3 is 8 pi over 3. So another perfectly valid name for the point A, 6, which we had set 6, 2 pi over 3, it could be 6, 8 pi over 3, right? And that would mean initially we had a rotation of 2 pi over 3, but we could go around one more time, right? So if I go around once and then a second time, I would get 8 pi over 3. That's another valid name for this angle. How else could we name it? Instead of going 2 pi over 3 in the positive direction, I could think of rotating in the negative direction. So I could also name this point as 6, negative 4 pi over 3. All right, how else could we name it? We could think about using a negative radius, right? So if we use a negative radius, then the angles that we want are actually on the opposite side of the origin, or of the pole, I should say. So we want to use the angles that are 180 degrees away, or pi radians away. So in this case, we're going to have negative 6, right? And we could be at 5 pi over 3. So let me explain that. So this ray right here is 5 pi over 3. So if we're on 5 pi over 3 to get to point A, we really are going to go negative 6 units. We're going to go opposite or across the pole on the ray that is 2 pi over 3. Okay, let's try another one. So we've had both r and theta positive. We had r positive and theta negative. We had r negative and theta positive. Let's see if we can write one with both r and theta negative. Okay, so we want to try to write one with negative r and negative theta. Okay, so negative r, that's obvious. We only have one choice. That would be negative 6. Well, how could we write a negative angle for this, right? How do we get -6 and a negative angle? So to get -6 and a negative angle, we need to name this rotation to -5 to 5 pi/3 with a negative angle, and that would be -pi/3. So -6, -pi/3. These are all perfectly valid names for the same point. We can name more. Let's think of the one we just did. What if we do -pi/3, but we think about rotating a full rotation first? So we went all the way around and then to -pi/3. This would be -pi/3 minus a full rotation. So -2 pi or -6 pi/3. This would be -7 pi/3. That's another way to name that angle. So we could name this as -6, -7 pi/3, just getting a coterminal angle to the previous one. We could take -6 and get a coterminal angle to 5 pi/3 by adding 2 pi. So I could get -6, 11 pi/3. That's 5 pi/3 plus 6 pi/3. So to summarize, with rectangular coordinates, we have a point x comma y. This should be up here. Each point has a unique representation. However, each point in the polar coordinate system has infinite representations. We can continue to change the angle measures, both with positive and negative values for r. Okay, let's do one more example. We've got a point 3, -3 pi/4, and we want to name that in different ways. So I am going to go ahead and plot that point. I need to find out where 3 pi/4 is on this polar plane. Remember, pi/4 cuts pi/2 in half. So that's actually going to be, this was 30 degrees, 40 degrees, 50 degrees. So pi/4 is actually not drawn. So I'll draw it in. This is pi/4. So we know where the pi/4s are, and we want to plot -3 pi/4. So -3 pi/4, and I've got to find that as well. 1, 2, 3, 4. So that's in the middle between pi and 3 pi/2. So this angle right here would be -3 pi/4. It also can be named as 5 pi/4. That's another way to name that same amount of rotation. Okay, so let's go ahead and try to plot -3 pi/4. So if we rotate -3 pi/4, that would put us on this ray, and then we're going to count out 3 circles, 1, 2, 3. So this is, let's call this point B. So this is point B, which is -3 pi/4. And now we can think of other ways to name it. So let's name it with a positive r and positive theta. So positive r, we would still have 3. And a positive theta means we want to rotate in the positive direction. So rotating in the positive direction to get to the same ray would mean we're going to rotate around here, which is a positive rotation of 5 pi/4. So this would be 5 pi/4. Let's name it with a negative r and a negative theta. So if we're going to be at a negative r, that means we need to rotate 180 degrees or pi from where we are, which will put us up on the ray at pi/4, which I drew earlier. So let me show you that. So we're going to be up here on this ray now. That's 180 degrees from -3 pi/4. So if we want a positive angle and a negative r, we have to be on positive pi/4. So we'll think about this, but then we're moving in the negative direction, which is what we want. So I'm going to name this as -3 pi/4. I actually did the last one first. And then we want a negative r and a negative angle. So negative r and negative angle means we're still up on this pi over 4. So we're still on this ray, but we want to name it with a negative name. So let's see. I will try to draw that. This is getting rather messy, but hopefully you've been following along. So I want to name this angle in a negative direction. I'll grab a red pen. So I want to get here in the negative direction. So that would be that angle I just drew. And that angle negative is negative 7 pi over 4. The other way to think of it is take pi over 4 and subtract 2 pi, get a coterminal angle. So negative pi over 4 minus 8 pi over 4 is negative 7 pi over 4. So a negative angle is going to be negative 7 pi over 4. And the negative value for r is negative 3. So in class, we're going to do a couple more examples of naming points to practice, but I hope you've understood this introduction, and please ask questions when we meet in person.